When you flush a toilet, where does that water actually go? And more importantly, what invisible threats are hiding inside it? In the 19th century, city planners had a straightforward priority: move waste out of sight. They laid basic pipes to carry the problem away from the home and into the nearest available space. But the adoption of the indoor water closet changed the math of urban living. We were no longer dealing with small, dispersed amounts of waste, but a massive, centralized flow that the environment wasn't prepared to handle. As cities like Stockholm expanded in the 1860s, they managed this volume by dumping raw, highly concentrated sewage directly into their own rivers and lakes. Local waterways were quickly overwhelmed. The volume of floating waste created unbearable stenches, and popular events like the annual public swimming race had to be canceled to protect the health of the competitors. Shifting waste from the bathroom to the river didn't solve the crisis, it just changed the location. To keep cities habitable, engineers had to move from simple plumbing to physical filtration. The first major technological interventions relied on passive physics. In 1906, Carl Imhoff introduced a tank designed to separate waste through gravity rather than active cleaning. Inside, heavy solids sink to form sludge, while lighter debris floats. This leaves a layer of clear water in the middle. This layer was discharged back into rivers. It looked clean, but closer inspection reveals microscopic threats remained completely untouched. By focusing entirely on removing the visual nuisance, early engineers unintentionally allowed deadly pathogens to flow freely into the public water supply. Devastating outbreaks of cholera eventually proved that visually clear water could still be lethal. In 1913, Edward Ardern and W. Lockett discovered activated sludge, a process that moved wastewater treatment out of the realm of passive mechanics and into applied biology. By pumping large amounts of oxygen into the wastewater, engineers found they could rapidly cultivate massive colonies of hungry microorganisms. These bacteria consume dissolved organic waste and oxidize toxic ammonium, expelling safe byproducts like nitrate back into the water cycle. We learned to fight nature with nature, transforming treatment plants from simple settling basins into massive, living biological engines. This combination of mechanical settling and biological digestion worked so well that it quickly became the global standard for city infrastructure. Municipalities committed fully to this design. Following the 1930 release of what engineers called the Wastewater Bible, cities like Stockholm began building the vast, multi-basin biological plants that still define our landscape today. This infrastructure launishly eradicated waterborne plagues in urban centers, securing public health for nearly a century. We had engineered a self-sustaining biological loop, operating on the assumption that bacteria could break down anything we flushed away. Today, if we look past the microscopic level to the actual molecular structure of our waste, this century-old biological solution is failing. Our waste now contains synthetic compounds that do not exist in nature, things like pharmaceutical residues, nanoplastics, and PFAS, often called forever chemicals. Because these molecules are synthetic, the bacteria used in traditional treatment cannot absorb or break them down. They simply float past the biological defenses. Many chemicals slip through at parts per trillion levels, while others actively toxify and kill the beneficial bacteria the plant depends on. Because we have invented chemicals immune to nature's recycling tools, our biological safety net is now full of holes. Ensuring the safety of our water now requires an exhaustive chemical operation to filter out the synthetic materials of our own creation before they permanently alter the environment.